Our last question is what proportion of the sample will have a mean useful life between 34.5 and 36 hours?
Okay, earlier we found that the area between 34.5 and 35 is 0.1736, and the area between 35 and 36 is 0.3186. We'll just add both of them up, and we find that the area between 35.5 and 36 hours is 0.4922.
And found out what our mean is. So we added 5.5 to 3238 and found out what our probability is, which is 8238.
Okay.
Now, the question is, the Quality Control Department employs 5 technicians during the day shift. Listed below is the number of times each technician instructed the production foreman to shut down the manufacturing process last week. Now, here's what we're looking for. How many different samples of 2 technicians are possible from the population? And that's the first one. So to get that, we use the combination problem. And given that there are 5 different people to choose from, it's asking how many types, 2 specific people combinations. And then you follow your formula, just plug in the numbers, and you get 10. Now, then it asks, list all possible samples of 2 observations each and compute the mean of each sample. Now for that, right here, we have them listed out, Taylor, Hurley, and then basically all you gotta do is look over here. You got Taylor's 4, Hurley is 3, you add them together, divided by 2, you get 3.5 to get all possible samples. Then you just do the same thing for each person. Taylor, Gupta, you can't really reuse them, so they all will be used. Follow the format, and then you can also take the probability for later purposes. And then C? C asks, compare the mean of the sample means with the population mean. Now, as you can see in here, basically you gotta add all previous numbers up. These 3.5, 4.5, 3.5, 3, 4, 3, 2.5, 4, 3.5, 2.5, and you divide it by 10, and that gives you 3.4. And the population mean, you just add 4, 3, 5, 3, and 2, divided by 5, gives you 1705, same answer. So, they both are the same. Then it asks to compare the shape of the population distribution with the shape of distribution of the sample mean. As you can see here, population distribution right here is represented by X. Down here, the mean is 3.4. Probability doesn't go past 0.4. 0.2 for 2, 4, and 5. 0.4 for 3 only because it does have more. Population sample, there's more 2.5 X bar represented by X bar on the X-axis, probability on the Y-axis, 3.4 mean, and as you can see, 3.5 is the most because it is shown the most. The shape.
The shape of the sample mean tends to become more normal than the population distribution.
The population values are relatively uniform in shape. The distribution of sample means tends toward normal distribution.